thank you for joining me. Today's session is Injecting Intelligence. I have to say my wife is baffled as to how I'm associated with anything to do with the word intelligence. So this first event is going to be a fireside chat, and our esteemed, the subject of the fireside chat is John Clark. So John, come on and I'll introduce you. So John is Lockheed Martin's Senior Vice President of Technology and Strategic Innovation, driving technology strategy and investment across the company. He's also responsible for Lockheed Martin Ventures, which invests in early-stage companies, developing technologies in strategically important areas such as artificial intelligence, which is what we'll be talking about today, robotics, cybersecurity, space, advanced materials. And he started out as a materials engineer. Previously, John was Vice President General Manager of Lockheed Martin's Advanced Development Programs, better known as Skunk Works. He's now a seasoned executive, but he joined Lockheed as an engineer in low observable materials. He went on to become a Skunk Works program manager. He moved over to aeronautics as chief engineer and vice president of engineering technology, and then he came back quite recently to take his new role at corporate Lockheed. Looking way back, he has a bachelor's degree in chemical engineering from the University of Colorado Boulder and a master's degree in business administration at Texas Christian University. So welcome, John. Can I just begin, your first job was as an engineer at Skunk Works, working on materials. You went on, moved up through the program management, and you went to aeronautics for a while, but you came back and then ran the Skunk Works. Now you're running, you're overseeing technology across Lockheed Martin, yes. Massive corporation in many, many areas of defense and aerospace. Is what you learned at the Skunk Works still relevant and important?
Yeah, it absolutely is. I think one of the things that's actually very motivating and exciting is that right now in this role, especially with one of the things that you highlighted, our Lockheed Martin Ventures Fund. We go out and invest in small companies. So we have a $400 million fund that we go and invest in small technology companies that are emerging with some new technology. And invariably, as I go and visit these companies and get a sense of what they're doing with their technology, they've got some connection back to the Skunk Works with how they're trying to start their business and how they're trying to run their business. And so you'll see either Kelly Johnson's 14 Rules, which I'm a big proponent of, or you'll see elements of, most notably, you'll see SR-71s adorning their artwork on the walls. Just really tying back to the lineage of where, candidly, all the true innovation started, and all the way back with the XP-80 and Lulu Bell, and getting that done in 143 days.
Cool. I was glad that culture still lives on and still inspires after all this time. So we're here to talk about AI specifically, but I wanted to begin by just asking you what you see as to put it into context, to say what you see are the kind of like the important technologies going forward, the key ones, so we can know where AI fits into that.
Yeah, so how I'll approach answering that, Graham, is that, so what's interesting is that, the very first artificial intelligence project that I had embarked on was 2007. The project back then was centered around trying to evaluate and make a determination around the intent of an adversary based on the actions that they're taking, trying to understand, behaviorally what happens when you see, a certain radar turn on, and then you see another radar turn on, and then you see a movement of a specific set of assets. Could you derive what their intent is, from those set of actions? And at the time, we did a healthy amount of work surrounding deeply layered neural networks and trying to understand, could we get that level of behavior? And the short answer was, at that time, the computational density was not there to be able to go through and push through all that. And so, where things are at today is that, in large part thanks to NVIDIA and the introduction of CUDA, that's helped bring or unlock a whole lot of computational capacity and capability, because a lot of the technologies that you read about today with artificial intelligence, they're actually not new technologies. The idea of reinforcement learning, that existed, way back when. The idea behind, different versions of expert systems, that existed way back when. I think that what has been new and different now is that because of that ability to process so much data in parallel at scale, that's now got us to another level of actually applying these technologies in new ways. So with that kind of foundation, I'll say that now being able to actually see how reinforcement learning and different varieties of machine learning apply, I think that is a very important area, especially in our DOD ecosystem, because there is a requirement for stuff to work reliably, responsibly, and ethically. And having that element of, I'll call it like a bounding box of behaviors that you operate in, I think that's very important. And then, adjacent to that, exploring the generative AI space and how generative AI is going to apply. And generative AI doesn't have the deterministic flavor to it. I'm sure many of you have, used Grok or used, ChatGPT in their underlying models, but those frontier model providers don't have, determinism is not their forte. In fact, you'll find that, candidly, I was going through and using ChatGPT not too long ago, and it was messing up on basic math. It could not, it failed at subtracting 80 from 42. And when I pointed that out, that's, oh yeah, you're right. Well, thank you. Yes, I know I'm right. But, it will authoritatively answer a question based on what it thinks it's come up with. And so I think that there are things like that in the generative AI space, there's a lot of growth to be had there, and taking the possibilities of that technology and then being able to apply it into our ecosystem, but doing it in a responsible way.
So does that mean that you kind of develop your own internal grok or something with your data, or can you somehow or other?
Yeah, so the short answer is no, at least within Lockheed Martin. When you look at the amount of money that's being poured into the frontier models on the commercial environment, we can't match that. The entire DOD ecosystem can't match that. And so if somebody's trying to roll their own, good luck. I think it's a fool's errand. But I think that what we can do is that we can take advantage of the frontier models that are out there, and how we're specifically approaching that is that we are working with the different model providers, and we are constantly iterating. And right now, Grok 4, they appear to be the one that's inched ahead. I'm sure in 3 or 4 weeks there'll be a different one. Google will be out front, and then then OpenAI will be back out in front, and then they'll have that constant race. But they're throwing incredible amounts of money at it, and so much so that you now see Meta investing incredible amounts of money to go get some very top-notch people, and then you're actually seeing this. What I just find is actually pretty. It's actually great from an economic perspective. You're seeing how AI is driving lots of other adjacent elements like our power grid and our infrastructure and things that we need in this country commercially, because our power grids, gosh, most places it's over 100 years old, and it's scabbed together and very vulnerable, and having AI and the power demands that come with that actually go through and impact all of our ecosystem, I think is healthy. But again, that's not something that we can do from the DOD's space, because that's just the amount of money in it is just not there.
So you mentioned different types. You mentioned generic AI, you mentioned machine learning. So Tim Persons, right at the beginning of this conference, said he hated the term AI. He felt that augmentation of human capability, I think, was better. Are there specific types of AI that are very relevant to what you do at Lockheed Martin?
So I think that the answer to that is that we will find that most flavors of AI we are using in some capacity, but it all becomes centered around what specific use case or what specific problem we're trying to solve. And so how we've approached this, and I'll do some compare and contrast, is that you will see folks, and so I very much align with that statement that AI is an overloaded term, and it's like AI for what purpose? What are you actually doing, and how is it broken down? And you'll see, some of these more recent startup companies that they talk about having their, artificial intelligence basically being the, pardon the Lord of the Rings analogy, but the one AI to rule them all. And I'm a, antagonist to that because not only do I think it's wildly uninformed, I also think that there are a lot of mechanisms that you're going to see as these different technologies, they all apply in a modular fashion. There are places where reinforcement learning is the right thing to go do. There are areas where you're going to have that more human interaction that sits more like the chat GPT, where you're having a dialogue and you're using the underlying frontier model to elucidate or bring out more information for a human to consume and then make decisions from. And then there are going to be other places where you're actually putting AI in to go do inferencing down at a pixel level on an image. And so it really comes down to it needs to be done modularly, and then you apply the right technology to the right problem set inside of that AI ecosystem. And so I think that AI, in some ways, if you take a big step back, it's very much like the late 60s when the calculator turned into a computer. And now we have computers that are a part of everything that we do, and it's just natural. I think that AI is going to kind of fall in that same camp that it is the wild thing right now, and it is going to be driving a lot of what we do, but it's inherently just going to find itself as part of the fabric of everything we do going forward, and it's not going to be this unique thing or this boutique thing. It's just going to be mainstream, and it'll have that same wonderful growth curve that computing had for our country in the the 70s and 80s as a byproduct of the inventions that were made in the late 60s.
So at this stage of AI, how do you deploy it as a company like Lockheed Martin? Do you kind of train every engineer to use AI, or do you have a core team that gets thrown problems, develops AI solutions, and throws them back?
That's just wild, wild west. We let it all just go, throw it out there and see what happens. No, I'm just kidding. No, so how we approach it right now is that we have done our best to try to democratize it in such a way that if I have a specific use case sitting at my desk and I'm inundated with emails that I really don't want to deal with, I can put together a little AI agent that can go deal with those sets of emails and catalog them or respond to them in a certain way. And I can put that together for myself. But if that then turns into something that is more widespread and an entire department needs to go use that, then at that point we put a framework around that so that it is managed accordingly and from a scale perspective so that we understand the user impact, the computational impact, because one of the things that there's, as with everything, there are, in the spirit of conservation of problems, AI creates other problems like the cost of GPUs and how many GPUs, and if we've got engineers that are out there using AI to do basic arithmetic, which as I just said, it's not always great at. Now we're consuming GPUs, which then we're consuming tokens, which then is adding cost to our ecosystem that you could have done that more conventional ways. And so we have to put some framework around how we introduce it to the entire workforce. And so we do not have a setup where everybody has to be a full-up trained and authorized user of the capability. But there are capabilities. So one of the tools inside of our ecosystem we call Genesis. Genesis right now has 70,000 users inside of Lockheed Martin, where they go out and they use the AI tools that we've created within our Lockheed Martin AI Center team at corporate. And so 70,000 just for reference. Lockheed Martin's got 120,000 people in it. So over half of our employee base is using AI on a monthly basis, based on how we're collecting our metrics. But that has been curated at a specific level in terms of how they use it and what they use it for, so that it isn't the wild, wild west, and we can keep some reins on how the resource is consumed and then how it gets deployed across the ecosystem.
Is there like a trigger where it gets to a corporate level tool development where you say I want, I have like a CAD tool now, but I need kind of like an AI equivalent in some area that's going to be a powerful tool that unlocks something. Is there a core team that you've got that's pushing that edge as well?
Yeah, so within the Lockheed Martin AI Center, so we have 250 AI-specific engineers. That's what they do, is that they're building those new tools, those new capabilities, and introducing them into our environment. And so that group, they are out and working amongst the rest of the Lockheed Martin team, identifying core problems, and then when they, I have identified core problems, then they'll go work those, build some core capability. And so, one of them, I'm sure many of you have heard about, but so in the Red Sea, we introduced AI, and we were doing over-the-air updates for the Aegis radar. And so the use case here is that, historically, the radar on Aegis had been tuned to look at high-value targets and basically try to remove clutter. And in doing that clutter suppression, part of the clutter suppression process is to take things like birds and slow and low-flying objects off of the radar screen because they weren't a threat to the ship. Well, ultimately, what the Iranians and the Houthis had done is that that was their attack vector, is that they were coming in at low speeds with the Shaheed, and then trying to intercept our Navy. And so that became one of these urgent problems that we identified. We worked with the Navy, and we put together a process that allowed us to, we are exfilling radar data from Aegis every day. Overnight, we run our reinforcement learning algorithms against the data that has been seen in the back end of the radar, not what was signal processed and put on the screen for the user to operate against, but we actually operate off of the raw INQ data that's been processed to a level that we can get it back domestically. We then work off of that data, go through our algorithms, and then send back new files to update the radar for the next day, and work through a process with the Navy that allows us to maintain the determinism and the effectiveness of the radar while literally changing the parameters of that radar every single day at the start of the operating day on their clock. And so that's been very effective. As I'm sure many of you have seen, we've been very successful with Aegis, knocking down anything that the Houthis have thrown our way. And so that's evidence of where AI has been used as a tool, and what it's done is that there are behaviors that it's been able that with our reinforcement learning algorithms and some of the other neural network capabilities that we laced around it, is that we were able to pluck out the exact elements that historically would have been deemed as clutter, identify them as threat tracks, and still not just put everything on the display and have a naval operator having to figure out what to do with, birds and other terrain clutter and everything else that shows up on your radar scope.
Right. So I'm going to turn to some of the audience questions here, and here's one that was occurring to me as you were talking, and it's really to do with it's back to skunkworks, classified programs. The hurdles of bringing AI into classified programs and onto platforms that are highly sensitive. I mean, how do you tackle that? Do you have to fence them off in some way and do a completely separate, different approach? Or?
Yeah, I think that unfortunately, the answer to this is that it's dependent on your customer.
Right.
You will find where there are places where we have very, very forward-leaning customers, and the classified environment actually gives them a little bit more leeway to take risks and introduce new technologies and employ them in different ways. At the same time, recently we've run into some customers that, cyber is, it's definitely keeping them up at night, and the government's provision for that is to make it damn near impossible for anybody to do any work, because that's how we protect ourselves from the adversary. It doesn't really help us do work, but that keeps the adversary out of a network. And so it really does depend on the customer that you're interacting with. I won't say that it's necessarily just a classified or an unclassified element. It really comes down to the customer on the other side. I mean, the Aegis over-the-air example that I just highlighted, that was done unclassified with a classified set of data processes that underpin it. And that customer allowed us to go do it. We worked with them to put a process in place that enabled them to be successful. And so we really need the customers to just work with us on that. I don't think that the AI tools provide a unique or discrete set of behaviors or exceptions that you have to put in place in a normal authorization process. You just have to have a customer that's going to be willing to allow you to go use them.
So another question, which is another one that occurred to me, I was doing I was at a presentation somewhere where they were talking about the V280, the V280 program, the Bell V280 program, and it's the Army's first big model-based system engineering program. And they've kind of hitting a problem where because of security, they have two models. They have the government model and the industry model, and there's this constant interchange between the two.
Yes.
And the bandwidth is just getting unbelievably big, and how do you move these models, right? If we layer AI on top of that and have to start doing that interchange, does it make it better or worse, or?
So, I mean, any technology can, even a good technology employed the wrong way can make things worse. But, in this specific instance, in the use case you just articulated, I would say that, AI could actually help augment or benefit that problem, because you could go through and look at model changes, model deviations, and do the associated configuration and change management, look at things through a translation lens, and then bridge across with some form of replication to allow those models to bridge. It doesn't change the amount of data that you necessarily need to replicate, right, unless you go deeper into the core elements of the model. But I think you could help alleviate some of that problem. But again, what you just highlighted, that's a place where I think we have to find a way, and this is not an AI problem per se. It's a problem where inside of our DOD ecosystem, we spend so much time trying to protect data that we actually impinge upon our ability to do our job. And working with the government customer, one of the things that's frustrated me to no end is that the government will have a multi-level secure environment where you happen to go into their office, you'll find that they've got their top secret data there, and they've got their secret data there, and then they've got their SAP data there, and they got their SITK data there, and it's all on the same computer. And they're allowed to have that network touch all of those things. You'll nary find a place inside of the DOD contractor base that has that same construct. It's very rare. And in the places that you have it, it's not used as prolifically as it could be. And so if we put the right network ecosystem in place and still have the right cybersecurity protections in, it could actually alleviate a lot of these problems that I think are self-imposed or we're hurting ourselves with some of the anxieties. And don't get me wrong, China's trying to get into every one of our networks every day of the week, and that's one of the things I've tried to really highlight on the new entrants crowd and the venture capital crowd, is that they have to have a real appreciation for protecting their data and how the adversary is going to take their data and use it against them. But at the same time, there are lots of great technologies that exist out there that allow separation. And I'll use this as the direct corollary. And this is also a place where you see AI being laden or applied on the fringe of, is that our whole banking ecosystem. That's where it's one of the largest attack surfaces in the world, and that's where all the money's at. So there's lots of bad guys trying to get in and trying to break into the banking system, and yet you don't find you don't read every day about a different bank being hacked and money being exfilled from the banks. And I'll emphasize that they have the same insider threat problems that we do. They could have somebody that goes in the back room and moves an Ethernet cable from one switch to another, or swaps a switch out for another that then channels data. There's all kinds of things there that they're vulnerable to the same things that we're vulnerable to. And now they're applying AI. If you think about the stock market and the things that are going on now, they're using AI looking for behavioral trends and patterns, and that's all laying on top of that strong, financial system and able to go leverage that. And so I think that those are places that in our DOD ecosystem, I think we could learn a lot from what's happening in the banking system and not self-impose so many of these constraints that we operate in.
So you mentioned China there, and we were talking earlier about I think it was an announcement yesterday about, it says here, removal of the regulatory barriers for AI. So the question that we want to ask is the belief is the US is in the lead in AI. So the question is it? If it is, why? And then how does it stay in the lead?
Yeah, I think that our capital markets, I do think that we are in the lead, and our capital markets are what enable us to be in the lead. You think about how, right now you look at what Meta is doing, competing with Google, competing with Microsoft, competing with OpenAI, and then competing with XAI. Each of them are trying to drive at different things, and they have different approaches. And that innovation through competition is driving a whole set of new capabilities, and it's putting a lot of new content into our whole ecosystem to go explore. And they're doing it at a fast clip so that we're able to go use it, learn from it, iterate, do it again. And as I talked about earlier, the frontier model arms race that's going on right now, Grok 4 is in the lead for now. It probably won't be in the lead, in the next month. And so I think that is allowing us to stay ahead. Now, what's really kind of interesting is that that's all underpinned with, our semiconductor infrastructure and getting content from, NVIDIA, Broadcom, and then ultimately TRMC. And if we think about, ultimately one of China's most, if you really pull back why China is so enamored with Taiwan at the moment, I mean, there's certainly long-standing, cultural elements and reunification arguments that's made. But if you really pull back from all the noise, they need the semiconductors. They need TSMC, because China doesn't have that. And that's part of what we have within our market. And that's where, whether it was the CHIPS Act or, some of the other advancements that are being made right now to try to bring, foundries here that can be trusted and, introduce those into our ecosystem, that really becomes that foundation. And again, we're on the front edge or leading edge of that whole experimentation and development campaign that's going to allow us to stay in front. And I think that reducing some of the regulations that, one, allow all those infrastructure elements to come into play. We talked a little bit backstage. One of the things that I'm really excited about is that, I'm a chemical engineer, spent lots of time in college exploring nuclear and different power constructs. I think nuclear is may not be a popular opinion, but I think nuclear is the best power source. It's the cleanest, ultimately. If I said that, 10 years ago, pitchforks and torches would have been coming at me, and it's all solar, it's all wind, it's got to be green. But now everybody's actually taking a step back and they're having a realistic conversation about, solar panels aren't going to charge a 1 gigawatt data center powered by AI. You're going to have something else. And how do we do that responsibly for our environment? And now there's all these new companies out there, and there's a whole new ecosystem emerging with small modular reactors, trying to find ways to bring that type of technology to the U.S. and there's regulations that inhibit that. In fact, I won't call out the specific company, but one of the companies that I went and visited in the small modular reactor space, they're doing something very creative. They went to another country that didn't have the same regulations that we had so that they could be first to get their reactor in place. And kudos to them. They were trying to find their way, being very capitalistic. They're trying to find ways to get things to the market, go test the technology, and they went and found a place that would allow them to go do it. As we can relax our regulations and do it responsibly here, candidly, we don't need people running to the lowest common denominator with respect to regulations and environmental stuff. China already does that. We need to go find the places that, or we need to, embrace the right regulations here that allow people to run fast, and then, put the right framework in place so that it can then persist over time in a responsible way. And I think that that's the uniqueness that all of this AI stuff is really, it's challenging a lot of our ecosystem. And I think that's, as we look at all the regulations and some of the executive orders that have come out, as well as the content from yesterday, to enable us to stay in front and lead the way, it's got to be across that whole board. It's got to be at the silicon level, at the base. We've got to have the power to put these things in order, and then we've got to have the capital markets, flowing with funds for people to innovate and introduce new capabilities into our market.
Are there specific regulations that aerospace needs to fully exploit AI, or does it just build off of that sort of general regulatory revamp?
Yeah, at least with what I see in the environment right now, the commercial market is plowing all of the regulatory field that we need. There's nothing that I've bumped into that's unique to the DOD that we need to change from a regulatory perspective. Now, I will say that there is an adjacent challenge that we all have to navigate through, and that's kind of the responsible AI. And one of the challenges that we have here is that so our adversaries likely won't use AI as responsibly as we will. One of the things that in my career journey, I was responsible for building an autonomous system, and there were a lot of autonomy behaviors that we actually had to remove from the system because our user community couldn't have them in there based on our, how our government services ConOps operated. And so we had to actually make the system more human intensive by design. And that's one of the things that you see right now. There's a myriad of experimentation campaigns going on with our service customers, trying to understand how to navigate that. Where does the human interact with all of these machines? And ultimately, when you're looking for that accountability element, when the weapon didn't hit the exact target that it was intended for, where's that chain of custody end, and what human is responsible for the decision that was ultimately made that was deemed inappropriate? And given that we have that moral and ethical framework inside of our culture, which I think is great, we have to figure out how we navigate that when our adversary may not have that same thing. They don't care about collateral damage. If they, just not to speak to the larger elements, but you can see on our side, we celebrate the loss of a single soldier, and it's a big deal, and that's important to us, and it's celebrated with the impact and the sacrifice that they made, and we want to bring every American home. We want every ally to be safe when we're in these fights. If we look at some of the adversaries that we're dealing with now, they send their people out as the weapon. They're okay if they die. And that's just a paradox that as we apply AI in our systems and we're putting these behaviors in, how are they going to use them on the other side? And what does that mean? Do we artificially constrain ourselves in a way that puts us in a negative battlefront compromise because how we try to ethically fight the war? I think that's a challenge that all of us in this room and all of us in the DOD have to figure out how we navigate that effectively so that we can be on the moral and ethical good side of the equation, yet not compromise ourselves when it comes to an adversary that maybe doesn't fight within the same rules that we impose upon ourselves.
So that you're talking there about ethical use of AI, I want to now sort of say, what about appropriate use of AI? And this is kind of a bundled question. We talked about it earlier. There's a lot of talk about the AI engineer, and it's kind of the early stage. Take the AI, do the early stage engineer's role. How do you? And I'm going to bundle it a little bit here how do you? If you do that, if you use AI, how do you still give engineers the experience they need to make the right decisions with the AI? How do you? Linda O'Brien talked about the lazy engineer. How do you stop them overusing AI? And then how do you make sure that as a corporation, AI doesn't get kind of biased in the wrong direction? those sort of issues. I know it's bundled, so I don't know how you
no,
can unbundle it to the extent you want to.
Yeah, I think that as that dimension of AI is applied across our entire ecosystem, I think one of the things that we're all going to be, it really comes down to that same, construct that we just talked about with, the ethical use of things in the field. As it's inside of a business and you're operating, you still have to have that same, moral compass that's driving where decisions made and what checks and balances do you put, inside of the system. I think you can see right now the markets will respond accordingly based on what happens. And so I'll be abstract, but I think that folks will get the general gist. But when you've seen DoD companies just go totally toward cash, you've seen things happen in the engineering side because they were all about speed and getting things out to the field. Well, that had a specific set of consequences that then ultimately caused there's a whole myriad of dominoes that then fall.
Yeah.
Every business is going to be faced with that same complication or business existential evaluation to determine what risks can I take with the AI that I put in place in the event that, all right, it results in a weapon not working, a weapon going off course, an airplane crashing, and when root cause analysis is done, it tracks back and it's like, yeah, AI made this decision and nobody paid attention to it. I think that's something that everybody's going to have to come to grips with of how we navigate that. And I think that's a very challenging problem and one that I think that Lockheed's got a unique approach that we're going to tackle that with, and I'll keep that to ourselves.
Are you looking at ways to make sure engineers still get the experience they need to be program managers, to be whatever?
Yeah, I absolutely. I think that one of the interesting things that, in some ways, I'm going to maybe take a contrarian stance, that I think that AI may actually be more of a supercharger for those early career engineers because, one, they're going to be coming through an education program that's going to have AI interlaced with everything that they're doing. And if they immediately come in and they hit a bunch of drag of doing it a different way with older tools and without understanding, that's going to slow them down. It's going to create a different experience for them that you may not keep an employee that's excited about those type of technologies around very long. And so I think that there's an opportunity space where you actually use AI as part of your training curriculum, and where you understand how you want that engineer to come in. And how I've likened it right now is that you've got tech fellows or folks that have been around for 25 years and they know exactly how a certain process is supposed to run. Well, that person, they're unique and specialized in what they do because they're really good at what they do, and the business is rewarding them for what they do, which means they don't have a lot of time to train people either.
Right.
And so you have the other side of that problem, which is that you got an entry-level engineer that wants to go learn from the person that knows the best. Well, they don't have a lot of time to train.
Right.
And so you end up with that constraint as well. And so I think that if you look at it through that lens, that you can actually help solve that problem and help that early career engineer get some of the insight and knowledge that exists as a part of the process that the senior engineer knows like the back of their hand. I think that's going to help actually bridge them into our workforce much faster and make them more powerful.
Yeah, so I think Linda talked about the tech fellow in the box and the Kelly Johnson in the box. The idea of an avatar that an engineer can dialogue with or interact with to inform their decisions. You said earlier how engineering has become very sort of, as it's got more complex and the tools have become more specialized, engineers are very much in their kind of discipline and they don't think about the impact on the other disciplines. But it seems to me from what you were saying is that AI, that ability to capture that tech fellow expertise and make it available could help bring that connection back that was in those early days of, still is in the Skunk Works, I presume, but that sort of very tight connection with all the people involved.
Yeah, I think that being able to allow the engineering workforce to have more augmented means to interact with downstream parts of a design ecosystem, I think there's a lot of opportunity there where being able to interact with a large language model that has unique content that we've put into it based on our own design processes that they can use as kind of a check or an evaluation. I think that there's a lot of opportunity there to help accelerate the learning curve for the engineers by having that as a resource to explore. I think that that's one of the things that we think is going to help. But I will caveat that with one element. So one of the things that's interesting is that there's a lot of tools out there that you go learn in college. You're in college, you learn how to do finite element analysis, and you understand what that looks like. Well, you don't just do college-level finite element analysis when you're now developing the most sophisticated airplane being introduced into the DOD. You're going to do something more than just the college-level application, and I think that that's where you're still going to have that need for the engineer to shine, because they're going to have to understand more than just the basic mathematics of a process or a series of calculations to go do things. You have to actually understand a bigger and more holistic problem.
So the top question at the moment is one I know is a favorite of yours, is about the disruptors that are coming into DOD. But I first wanted to ask you very quickly, are we creating a new supply chain for aerospace? Is AI going to be a supply chain? Are we going to be drawing in apps, models, whatever it is, as a supply chain?
So I think that the answer is it depends, and it depends on how a business goes about embracing these types of tools. I think that, as I shared earlier, there are some, and it's a select few, but there are some that are in the construct of one AI to rule them all, and they're going to try to do everything organically, and they're going to try to vertically integrate from top to bottom with that tech. And I think that they're going to find out the hard way where that's going to be a limitation. Within the ecosystem that we're trying to build, and again, back to what we talked about just a little bit earlier, that you really need AI specific to the problem you're trying to solve. And the analogy would be is that I get my hammer to go put a nail to hang a picture. Well, there's also a sledgehammer in the garage.
Shoe.
Could use a shoe. Could use the back of my hand. There's a lot of other tools that you could use, but you put the right tool for the job at hand, and the other ones have consequences. If I use that sledgehammer, I'll get the nail in, but then I'll also have some sheetrock repair to do on the backside. And so I think that putting the right tool with the right use case is important. And so when you modularize that or break that down into that sort of thinking, that's going to create a very vibrant ecosystem of innovation, and that will come from all kinds of places, which means that, yes, we'll have a very good supply chain that we get to explore, and it's going to have contributors from the commercial environment. It'll have contributors from the DOD environment, and there'll be stuff that we make organically in-house, and it's going to be a nice, healthy mix of that. And I think that's what's going to ultimately, that's where you'll see the differentiation, is that those companies that are able to figure out how to find that sweet spot of bringing new stuff in from a supplier, getting it into their ecosystem, blending it with the things that they already have organically inside of their business, and then leveraging what's going to be driven by hundreds of billions of dollars of investment on the commercial side with the hyperscalers.
So disruptors. So Skunkworks is the classic disruptor, but we are seeing lots and lots of companies come into creation who are disruptors. A lot of them saying AI is enabling technology for the disruption. So how does a company like Lockheed, a massive corporation with how do you compete?
Yeah, so I think that there's a couple of things that I'd like to point out, with that question. So again, without naming names, you've seen a number of companies that they led with AI being the principal thing that they wanted to use as part of their ecosystem to go drive the value proposition of their business. And then, as anybody who's done any work with the DOD for a long-standing period of time knows, doing software business in the DOD is not lucrative. And all these venture firms or new entrants, they eventually figured that out, which is why suddenly you see them acquiring lots of hardware companies. And they start buying hardware companies that they can go put their software on because we're not going to accept their crappy software coming into our hardware. And so you then start to see that dynamic happen where suddenly they're trying to shift very, very strongly toward a hardware-based ecosystem, because ultimately, at the end of the day, you don't deliver AI without a piece of hardware attached to it. It doesn't just float in space. And so the construct is that these new entrants are now finding that, okay, we've got to go get some hardware. Oh, shit, that's capital intensive. I'm going to need more capital. I'm going to need a manufacturing space. And suddenly all these timelines come out, and then, you in the fake it till you make it construct, you start to see, hype put all around that of look at these great manufacturing places that we're putting together and everything else. But at the end of the day, they're just following the natural gestational process that all of our other, for the big primes, all of us naturally follow. And AI isn't markedly changing that introduction one way or the other. And I'll also, one of the other things that I've spent 25 years of my career in the Skunk Works, and of that, the preponderance of it was doing unmanned aircraft. And so I find it fascinating that over the last couple of years that suddenly drones have become all the rage. And I think that part of that is that there's some observations or lessons learned coming from Ukraine, where there's been some really great innovation, but it's innovation around trench warfare. You got folks that are fighting 20 clicks from each other. And effectively, it's if you just collapse the distance, it's what they were doing with rifles in World War I. They're first-person drones, and they're flying it into another human, and they're trying to obscure their position with jamming instead of holes in the ground. There's a lot of innovation happening, but drones are just at this point, they're just a fancy projectile that didn't get hit with a trigger. And so I think that when we actually take a step back and look at unmanned versus manned, there are some nuances there. You don't have human support equipment inside of an airplane anymore. There's not an OBOG system to feed oxygen to a pilot. And that helps. But oh, by the way, now there's more comm systems on there because you've got to share data everywhere that previously the human just processed. And so there's in the spirit of conservation of problems, you're trading some problems for another. And this idea that unmanned aircraft are magically so much different and unique than manned aircraft, it's just a fallacy. At the underlying, it's Newtonian mechanics still dictate how the hell those things fly and what you do with them. And so whether there's a human in it or not, doesn't matter. Whether we put AI in it or not, doesn't matter. AI can be augmenting a human in a cockpit, just like it can be augmenting an unmanned system in a processor in the weapons bay. It's just a feature or a facet of the airplane, because AI doesn't make my plane fly 200 nautical miles farther. It doesn't make it fly 2 Mach faster. So anyway, I'll get off that soapbox. That's just a little frustration with some folks out there that like to throw pot shots at manned aircraft when they've never built one.
My personal feeling is that it's great to see this velocity in product development. It's great to see companies pay for their own product development so they can offer something up. But in the end, you've got to have an effective weapon. It has to be something. That's what American military is built on, is the fact that you take that thing out of the box, it works. And we spend a lot of money making sure it works when it comes out of the box. But we still got to go through that with all these disruptors. They still have to prove at the end that it's effective. Because otherwise, all that velocity is not really worth anything.
Yeah, it's racing to the ditch. You end up in the ditch. And so I think that that's one of the great things that we have done as a nation, is that we do take a lot of pride in our products working at the end game, and the introduction of a lot of the venture capital funds. When I have had the opportunity to talk to the different companies that are out there and they are trying to do something new and novel, that's what I've tried to impress upon them, is that it has to work. This is not the fake it till you make it mindset that exists in Silicon Valley, because if we fake it and you don't make it, somebody died. And that's a consequence that I don't think that we should be accepting of in our ecosystem. We have to have just a self-governing encumbrance that our content has to work, and it has to work well so that it keeps our allies and our nation safe. And I think that that's something that we need, because I think that this ecosystem with venture capital is actually very good. It's going to bring in a lot of new innovation, and it's bringing in a lot of money that the DOD ecosystem would otherwise not have access to. And so there's goodness to that, but it has to be channeled properly. They have to understand the implications of the threat environment that they're going to operate in. They have to understand that it's not flying next door. You may have situations where it's got to fly 1,000 nautical miles or 1,500 nautical miles to be effective, or it's got to traverse an ocean with no navigational assistance and find ways when you're GPS denied. And there's all these different elements that they have to understand the environment that you're going to walk in with an adversary before you really state that your technology is the end-all be-all. And I think that's one of the things that I think all of us, where we have that opportunity to work with the new entrants, making sure that they see that and they understand that, because ultimately that'll try to get that value, that investment that's coming in that benefits us all, actually getting some return on it as opposed to it just being another defunct company.
So I've got to take the most popular question here. Probably going to be the last one. It said, will AI become good enough to replace human pilots? Is it even the right question, I wonder?
Yeah, so I guess I'll not take the bait directly with the question, because I think that again, we're not removing humans from the system. Humans are going to exist somewhere in the ecosystem one way or the other. And today, one of the interesting things that, so AI absolutely has some capabilities that, I'll talk to one of them that we did within the Skunk Works a few years back. We called it Mad Max. And the AI behavior specifically was looking at how you could burn off the kinematic energy of an inbound weapon to avoid being hit by an air-to-air missile. And the Air Force pilots are taught a series of maneuvers to help burn off that energy from the inbound weapon. And we introduced AI algorithms to start to drive an outer-loop control mode to burn off that energy. And what we found is that there were several cases where the AI did do better than the human. But once the human saw that behavior, then they were able to do the same thing. And so I think that there's really an and in that construct. It's not an either or. It's going to be an and where things are going to benefit. Really, the only limitation that exists now, if you look in the ecosystem, and in fact, I will pick at one of them that's been a historical sore point for me personally. So the U-2, the best ISR airplane that exists in the ecosystem that's not an ISR or an LO asset, by far the best. But it's limited by the human in the capacity that they can only fly for 14 hours. That's the limitation that the Air Force puts on them, is that they can only fly 14 hours. But what's interesting is that, so the Global Hawk, it can fly 28, 30 hours. It flies longer. But it can't take off in the same wind conditions because it doesn't have the pilot that can make those accommodations. It can't, I could go through a whole litany of limitations, but I won't. Sorry, the Northrop folks in the audience. There are issues that in the unmanned situation, the pilot actually accommodates for. Will those relax over time? Sure. But it's all going to be still driven by the Newtonian mechanics that dictate a flying machine.
Yeah, well, thank you, John.